So consider the graph f of x equals ax squared plus bx plus c, where a doesn't equal 0. Should look familiar to you. That is a standard form quadratic. And there's a couple things that are really easy to find in this equation if we know the formulas. So a couple of you are going to make a note card as we go along, and I would write down this equation, f of x equals ax squared plus bx plus c. And that's all I would write. And then underneath it, I would write down the next part, which says the y-intercept is 0, c. So I put y-intercept, and then the order pair 0, c. There it's written as an order pair. The next letter, B, here, says axis of symmetry. By the way, I oftentimes abbreviate axis of symmetry as AOS. I would write down AOS on your note card as well if you're making a note card. And the equation for the axis of symmetry is x equals the opposite of b over 2a. And I kind of squeezed that in, so I'm going to write it bigger off here to the right. It's the same thing, just so that it's just not so crammed in. The opposite of b over 2a. Technically here, it's that negative sign. It's out directly in front of the fraction, is where it is. And I would write that down on your note card if you're making a note card. Which brings us to letter C here, which I'm not sure if this one's going to help you on the note card or not. I'm going to let you decide. But the x-coordinate of the vertex comes from part B. It's the opposite of b over 2a. And what I oftentimes like to do is, the vertex is an ordered pair. I usually like to write it as an ordered pair. That's not really what the blank has there, but it's the opposite of b over 2 times a is what that red value is, and then add comma, a blank. We're going to use this value to find the y-coordinate by plugging the x value back into the function and solving for y. One other thing that I forgot to talk about is what is the axis of symmetry, back there on letter B, the AOS. It is a line that cuts the graph in half. And what happens is, if we fold along that line, the right half of the graph will land directly on the left half of the graph. And we're going to graph here in a few minutes, so I will be sure to point that out. So let's look at a couple of examples here. And what we want to find is we want to find the equation of the axis of symmetry, the vertex, and the y-intercept written as an ordered pair. And we can fall back on what we did in the last unit, which is to say A is 1, B is 10, and C is negative 27. I'm going to go out of order here, but in terms of the list above, we talked about the y-intercept first. What we said for the y-intercept is that the y-intercept is 0, c. Well, c in this particular problem is negative 27. So our y-intercept, where the graph crosses the y-axis, is at 0, negative 27. Our equation of our axis of symmetry is determined by this formula. Use the formula x equals the opposite of b over 2a. So let's fill that in. X equals the opposite of b. B is 10 divided by 2 times a. Well, if we simplify that a little bit more, we get 10 divided by 2, the opposite of 10 divided by 2. And 10 divided by 2 is 5, and in fact it's the opposite. Notice what the blank part says. It says the equation of the axis of symmetry. Don't just write down negative 5. Write down x equals equals -5. And I am really picky about that, and any other Algebra 2 teacher is going to be picky about that. X equals is really important because it's an equation of a line. Well, now that we know that, we can find the vertex here. It's going to be -5 something, that value that we just found. And to figure out what it is, we're going to take this value of -5 and we're going to put it back into our function wherever we see x. So our function is y equals x squared. So this is going to be -5 squared plus 10 times -5, putting that value of -5 back into our equation, minus 27. Well, we can type that into our calculator, and eventually what's going to happen is that we figure out that this value is -52. Let's try another one. Label the problem. A is 2, B is -12, C is 7. And once again, we can figure out the equation, the ordered pair for the y-intercept because we know the value of C. This one's going to be 0, 7, 0, 7. We can calculate out the value of the equation of the axis of symmetry. It's an equation. We want to make sure that we're going to write x equals, so maybe we write it at the start so we don't forget. So let's calculate. We're going to use that formula again. X equals the opposite of b, which is -12, divided by 2 times a. Well, what happens when we get a double negative? We're going to get a positive. So this is really going to be 12 divided by 4. 2 times 2. And 12 divided by 4 is 3. And we already wrote down the x equals. But remember, any Algebra 2 teacher is going to be picky. X equals 3. But once we figure out that x equals 3, that 3 is going to be used over here to find our vertex. Once again, I can recommend, well, actually, let me show the work here. It's going to be y equals 2 times 3 squared minus 12 times 3 plus 7. You can type that in. Or let's use our store button. So we're going to type in 3 store x, enter, and then we type in 2x squared minus 12x plus 7, and we get our y value of our vertex, which is -11. So you can do the computation here, or you can use the calculator to get our value of -11. And that's how we find some information of about our quadratics with our calculator. Well, we have standard form, but there's another form. In the second form here, notice it says finding the vertex from vertex form. So a quadratic function, what we were just talking about, is in standard form when we write it as y equals ax squared plus bx plus c. That's what we've been working with so far today. The thing is, we have to have an x squared term. So that's what the rest of the sentence says. Where a does not equal 0. But there's another format. The quadratic function can also be written as f of x equals a times the quantity of x minus h quantity squared plus k. This is called the vertex form. And if you are making a note card, I would write down the equation. F of x equals a times parentheses x minus h squared plus k. And write vertex form beside it. And now, some information. The turning point, also known as the vertex, I oftentimes abbreviate as TP. So if you're writing something down on your note card, I'd write TP. The turning point of this is H. Okay. Coming straight out of that formula. The axis of symmetry, which I also abbreviate again as AOS, axis of symmetry, is still an equation, and it's x equals h. I only write down underneath the line because I couldn't fit it in very well on the line. It's a tight squeeze. Maybe you want to write it off to the side on your paper. I would also write that one down. But I don't know that I would write down C, at least just yet. So our turning point, our vertex, is HK. Our axis of symmetry is x equals h. But there's one more thing. If a is greater than 0, so the number in front of the parentheses, if it's greater than 0, our graph is going to open up. And our turning point, consequently, is going to be a minimum. If a, the number in front of our parentheses, is less than 0, our graph is going to open downward, and our turning point, consequently, is going to be a maximum. So what happens is our picture is either going to look like this, where our turning point is the lowest point on the graph, or our quadratic is going to look like this, so opening downward, where our turning point is the highest point on the graph. And we've talked a lot about the graphs, but we haven't actually done one, so let's turn our paper over and look at a picture. And as we take a look here, what I sometimes find helpful is writing on top of the formula. I'm going to make this a little bit bigger. So this is y equals a times x minus h plus k. Because the turning point in vertex form, this is an equation, this is a quadratic that's written in vertex form. The turning point of this graph is going to be -3, -4. Well, what some of you are thinking is, why did you write -3, -4? Well, in the original equation, it's x minus 3. Sorry, x minus h. But in our equation, it says x plus 3. So since our equation was written as plus, I have to change the sign. And in general, negative means change the sign. Well, -3, -4. I know we haven't done very much here, but this is our h, and this is our k. I'll label that right there. But let's type it in, and let's look at the picture, because I think it might help us. And I already have it typed in my calculator. Y equals parentheses x plus 3 quantity squared minus 4. And once you get it typed in, hit graph. Let's look at the picture here. And let's look at our table, because we want to graph at least 3 points. And in fact, I'm going to graph probably 5. But to get our picture, we're going to go to second, in table. And I'm going to scroll a little bit to get some more points for us. And if we graph -5, 0, -4, -3, -3, -4, -2, -3, -1, 0. And in fact, I could have graphed even more, but roughly we'll get a picture that looks like this. So if we didn't have in our mind already what the picture looks like, now we actually can look at this. Is our turning point a maximum or a minimum value? Well, our turning point is the lowest point in the graph, in this particular case, which means that this is going to be a minimum value. The equation of the axis of symmetry is x equals h. So now that we have h labeled, this is going to be x equals, and remember, that's where the Algebra 2 teacher is going to be picky, x equals -3. And you do not necessarily need to draw this in, but here's where it is. It is this line that cuts the graph in half. If we fold this graph along that dotted line, this right half of the graph is going to land exactly on top of the left half of the graph. The right half is going to land on the left half. Our y-intercept. Well, once again, if you've got a graphing calculator, our y-intercept we're going to be able to find because it's going to be 0 something. Well, when we go back to our calculator, it's 0, 5. So I'm a little bit off in my picture here, but that's what the calculator is there for. Roots, zeros. Where does the graph cross the x-axis? -5 and -1. If you prefer, and some of you do, that's -5, 0, -1, 0. Don't put parentheses around the -5 and the -1. Those are the two places where it crosses, but that's not an ordered pair. The ordered pairs would be written like I wrote there. The domain of this graph. Well, the nice thing is if we're working with a quadratic function, that means that we're working with a parabola that's kind of a smiley face kind of figure, or an upside down, which is a frowny face, maybe. The domain of any quadratic function is always all reals. And that's a way of stating all reals. For some of you, you might want to write that off to the side so you know what that means. And our range, when we're talking about range, we ask ourselves, do we have a high point? Do we have a low point in the graph? Well, our red point here is a low point in the graph. And we're going to have y is greater than or equal to the lowest point in this graph, which is at 1, 2, 3, -4. So this is y is greater than or equal to -4. In interval notation, it's -4 with a bracket around it, which means that -4 is included, and our graph is going to continue to go up and up and up and up to infinity. Infinity always has a parenthesis. Graphing calculator can be very helpful in these. Let's jump down to number 3. And once again, what you may like to do is y equals a times x minus h, 20 squared plus k. Because the first thing that we need to identify is what is the turning point in this graph. Well, this time it's x minus h in our formula, and it's x minus 2 here. So it's going to be 2, 9. The beauty of this is, if you don't know that, but you have a graphing calculator, you can figure it out. Because we can then go to our calculator and we can type this in. So y equals negative, and then it's x minus 2, 20 squared, plus 9. I need to turn off the first graph. And we get that picture. Why is this one the shape that it is? What made it go upside down here? Kitty? The negative. It's negative. Well, what we can do here is we can go second and graph to get to the table. And I'm going to scroll through my screen a little bit because I want points that fit on my graph. And here we've got some that'll work for us. So -1, 0, 0, 5, 1, 8, 2, 9, 3, 8, 4, 5, and 5, 0. And I know there's a lot more than 3 there, but that gives us a lot of information about our picture. Because what we also want to know is, now, is our turning point a maximum or a minimum? Is our turning point a maximum or a minimum? It's a high point. It's a max. By the way, the 2 is the h and the 9 is the k. Our axis of symmetry then is x equals h, which is x equals 2. That is the line that goes right down the middle of the graph. I don't need you to draw it in, but if you're watching the video, ask your Algebra 2 teacher if they would like you to draw that in. The axis of symmetry cuts the graph in half, so that the right half of the graph will land directly on the left half of the graph when you fold it along that dotted line. Luckily for us, we can see where the graph crosses the y-axis in this particular one. It's at 0, 5, which I'll mark in blue here. Our graph crosses the x-axis for our roots at -1 and also at 5. If you prefer the order pairs, it's -1, 0 and 5, 0. The domain of any quadratic function, if it's actually a function, the domain is going to be all reals every single time. But in this particular case, as well as problem example 1 and 2 that we're not going to get to today, the range. You ask yourself, do you have a high point or do you have a low point in the graph? We have a high point, so this is going to be y is less than or equal to, because all of the points are going to be below that point. Our highest point is up here at 9. So it's going to be y is less than or equal to 9, which is, it's going to be -infinity to 9 in interval notation.